Good morning. Today's lesson is 1.7 Solve for Given Variables. Let's go ahead and take a few seconds and write that down on your unit title page. We are actually not ending the unit because I'm breaking it up into two tests. So if you want to go ahead and draw a line under 1.7, this will be Unit 1A test. And then everything below this would be 1B test. This is a really big unit, so I'm breaking it up into two tests. And these are your last notes for your first test. Okay, go ahead and go to your notes. We have been solving equations a lot during this unit, but now we're actually going to solve for given variables. Whenever we do this, it's called a literal equation, which is an equation in which all or part of the terms are expressed in variables, such as two-variable linear equations in mathematical and scientific formulas. So science, especially physics, has a lot of math formulas in it, okay? One example is the formula to find speed, which is speed equals distance divided by time. So for example, if I'm going 100 miles in 2 hours, I could divide that out. My distance 100 divided by time, and that would give me 50 miles per hour. So that's an example whenever we know the distance and time. But maybe we know the speed and time and want to find distance. So let's rearrange this equation to get distance by itself. So I want my equation to be d equals. So if I want to get d by itself, what do I need to do with time to get it to the other side? Well, I'm dividing distance by time, so the opposite of dividing would be to multiply. So I would multiply each side by time. So this would become, this is like t over 1, so I'd have t divided by t is 1, and then on the other side I have t times s. So I could write this as distance equals time times speed. So maybe I know how fast I traveled and how many hours it took me, so I want to figure out the distance. Okay, now we're going to rearrange it to solve for time. So if I just go with this equation right here, I want to get time by itself. So what's the opposite of multiplying by speed? That would be to divide by speed. So I would divide each side by s. S divided by s is 1. So I'd be left with time equals distance divided by speed. Okay, and you could check it. So we knew the distance was 100 miles and we were going 50 miles per hour. So what is 100 divided by 50? That would have equaled 2. So I know it would have went 2 hours, or it would have taken me 2 hours to go 100 miles at 50 miles per hour. So why would you need to solve for different variables? Well, just like these examples, if you want to rearrange your equation, maybe you know time and speed and you're looking for distance, or maybe you know distance and time and you're looking for speed. You need to take these equations and rearrange them to solve for different variables. So let's come down here and look at this compare contrast section. A lot of times what I see whenever students are working these problems, they get super confused because there's more than one variable. But I want to show you how it's the exact same process of just solving a normal equation. So let's look at number 1. If I have x plus 1 equals 7, and I want to solve for x, then what would I do to get x by itself? Well, I would subtract 1 to each side because the opposite of adding 1 would be to subtract 1. So I would get x equals 6. Okay, so you could actually solve it and get a specific number. On these literal equations, we're not actually going to solve it and get an actual numerical answer. We're just going to rearrange the equation to get a variable by itself. So the same type of equation, x plus y equals 7. But now instead of 1, I have a y here. And we still want to solve for x. So I'm still wanting to get x by itself. I want this equation to equal x. So in order to do that, I need to subtract y from each side, because the opposite of adding y would be to subtract y. So y minus y is 0, and I'd be left with x equals 7 minus y. Since I don't know what x or y is, we have to leave it as an equation like this. So all we're doing is rearranging the equation to get x by itself. Okay, let's try another one. If I have 4x equals 8, I want to solve for x. So I'm going to divide each equation, or each side of the equation, by 4. 4 divided by 4 is 1. So I'll be left with 1x equals 8 divided by 4 is 2. Okay, over here, I have a multiplication problem again. X times y equals 8, but this time we want to solve for y. So we're wanting to get y by itself. So in order to get y by itself, what would I have to do with the x to get it to the other side? Well, the opposite of multiplying is dividing. So I'll divide each side by x. X divided by x is 1, so I'd be left with 1y equals 8 divided by x. And I'd have to leave it just like that, because I don't know what x or y equals. Okay, moving on to number 3. I need to solve for x, so I need to multiply each side by 3. 3 over 3 is 1, so I'd be left with x minus 1 equals 12 times 3, which is 36. And then I would add 1 to each side, so I would be left with x equals 36 plus 1, which would be 37. So we're stepping it up a little bit. We've got 4 different variables here, and we want to solve for w. Notice that it's in the exact same place as what the x was over here on the left side. So we're going to do the exact same process. What was my very first step in order to get this w by itself, or what should my first step be? Well, the opposite of dividing by y would be to multiply by y. So I would need to multiply each side of this equation by y, which would leave me with w minus x equals z times y. Okay, I'm still wanting to get this w by itself, so now what do I have to do with minus x to get it to the other side? Well, just like we added 1 over here on the left problem, on problem number 3, we would do the same process and add x to the other side of the equation. So I'd be left with w, negative x plus positive x is 0, equals z times y plus x. So once again, we didn't actually solve this equation, we just rearranged it to get to get w by itself. Okay, last one. So my first step on this problem, since all of this is together in one term, I would need to add 3 to each side. So that would leave me with 4/5 x equals 1 plus 3, which would be 4. Then I'm going to multiply each side by the reciprocal in order to get rid of this 4/5. So I'd multiply each side by 5 over 4. Well, 5/4 times 4/5 is just 1, leaving me with 1x equals 4 times 5/4 would be 4 times 5, which is 20, and then 20 divided by 4, which would be 5. So I'd get x equals 5. We're going to go through the exact same steps, but we're only using these variables. So now I want to solve for b. Okay, notice that b is in the same location as the x was on the problem to the left. So my first step would be to add d to each side of the equation. So I would have AB divided by C. Negative d plus positive d is 0, and it would equal E plus D. Okay, remember the goal is to get B by itself. So I could multiply each side by C and then divide by A, or just multiply by the reciprocal, C over A. C over A times A over C would just be 1, because these variables would cancel, leaving me with just B equals E plus D times C over A. That one was a little bit harder. Also, since I'm multiplying this entire left side, I'm going to go ahead and put E plus D in parentheses. That way it tells me that I'm multiplying that entire expression by C over A. Okay, let's go ahead and move on to the next page. Here's some problems of an IXL that you'll do this week. The first problem, we need to solve for C. So we're no longer comparing and contrasting, we're just going to solve these literal equations for the given variables. So I want to get C by itself. That's all what solve means, is just get C by itself. So I need to do the opposite or the inverse operations in order to get C by itself. So it would be the opposite of adding A. Subtracting A. So I would subtract A to each side. And then I would also need to add D to get it to the other side. So that would leave me with B minus A plus D equals A minus A is 0 and negative D plus D is 0. So I would just be left with C, which is what we wanted. Okay, number 2, solve for U. So we're multiplying negative t times u times v. So what would be the opposite of multiplying? Dividing. So I would need to divide each side by negative t and positive v. So on the left side I would have w divided by negative t v, and it would equal negative t divided by negative t is 1, and v divided by v is 1, leaving me with just u. So we got u by itself, which means we did it correctly. Okay, number 3. This is a formula for area of a triangle. So area equals 1/2 base times height. We need to solve for the base. So I want to get the base by itself. Let me rewrite this one. Okay, the first thing I want to get rid of is this 1/2, this fraction. So I need to multiply by the reciprocal, which would be 2 over 1. 1/2 times 2 is just 1. So I would have 2a equals base times height. Now I need to get b by itself. So the opposite of multiplying by h should be to divide by h, leaving me with base equals 2 times the area divided by the height. So we just rearrange the equation to get the base by itself. Okay, number 4, solve for p. So I need to get p by itself. This one's a little bit trickier since p is already in the denominator. I'm actually going to multiply each side by p. That way I can get it out of the denominator. So p divided by p, because this is like p over 1, cancels. So I'd have pm equals k. Then remember I'm trying to get p by itself. So the opposite of multiplying by m would be to divide by m. So m divided by m is 1, which would leave me with p equals k divided by m. That's kind of just like the problems we did on the first page. Speed equals distance divided by time. You would rearrange it to solve for time. Okay, last one. This is the conversion between Fahrenheit and Celsius, which you should use in science a lot. So here's my formula. Celsius equals 5/9 times F minus 32. And we want to rearrange this equation to get it to equal Fahrenheit. And then we're going to determine if the temperature is 58 degrees Celsius, what is the temperature in degrees Fahrenheit? So this is an example of when you would need to rearrange the equation because you know the degree in Celsius, but you're looking for it in Fahrenheit. So the first thing we want to do is get rid of this 5/9. So I'm going to multiply by the reciprocal. So I'm going to multiply each side of the equation by this reciprocal, 9/5. Because 5/9 times 9/5 is just 1. So I would have 9/5 C equals F minus 32. We're wanting to get the equation to equal F, so then I would add 32 to each side. So we would end up with Fahrenheit equals 9/5 C plus 32. So now we could easily plug in our temperature in Celsius. Let me change colors here. So now if I want to figure out what my temperature is for Fahrenheit, I could plug in 58 for C for Celsius, and then multiply it by 9/5, and then add on 32, and then that would tell me what the temperature would convert to in degrees Fahrenheit. And then whenever you go ahead and solve that, it would equal 136.4 degrees Fahrenheit. So 58 degrees Celsius would convert to 136.4 degrees Fahrenheit.